Hey everyone, in this video we're going to be looking at the importance of having really good quality measurements. So what I have here is I've got a picture of a swimmer, and most of you know that during swim meets, the way we determine who the winner is by timing. The person who has the shortest time for the same distance is the winner. Now, the way you can measure time is if you have a small meet, you might want to use a stopwatch. So you have a timer, and what they do is they carefully time the swimmer going throughout the race. But the problem is this measurement can be affected by human error. There could be reaction time errors. It takes a while for the human to determine the start and the stop times associated with an event. So it's an okay measurement. The error isn't too bad, but we want to do better, especially the international competitions. So about 50 years ago, an individual invented a touchpad, and the touchpads, you can actually see them in the background of the picture. They're the yellow sections here, and we also have touchpads on the starting blocks. And what they do is they determine when the swimmer leaves the starting block and finishes the race without any human reaction time. So they're much, much more accurate. Most of them can time to the hundredth of a second. Humans can probably only time to a tenth of a second. So we have a much, much better quality measurement. And that's kind of the idea of measurements in science as well. We want to have the measurements as close to the true value as possible. So that's what's represented by this arrow and bullseye analogy. You want to have your bullseye. Your bullseye is the true value. You want to have all of your measurements very close to the bullseye, and you want to have the measurements consistent with each other as well. So we have terms. We use the term accuracy to tell us how close the measurements are to the true value, what they should be. So if you've got high accuracy, your measurements are really close to what they should be. If you have lower accuracy, they're not quite as close. We also have precision. This is the consistency of the measurements relative to each other. If you've got high precision, it means that the measurements are really close to each other. They're clustered together. If you've got low precision, the measurements are all over the place. They're not very consistent, and you probably don't have a lot of confidence in those measurements as a result. So we want to have high accuracy and high precision in our measurements as much as we can. So this applies to anything. We could be, measuring mass, time, whatever quantity it could be. So let's look at what you have in your workbook. So in your workbooks, you have the following page, and basically it defines what accuracy is. So accuracy is the closeness of the measurement to the true value. So let's use an example. What I have here is I have two students, and they want to measure the acceleration of gravity, how quickly gravity accelerates or speeds objects towards the Earth. So the true value is 9.81 meters per second squared. That's what it should be. Well, two students did a measurement. One did a measurement at 9.85 meters per second squared, the other one 8.89 meters per second squared. Who has a better measurement? Well, whoever is closest to the true value. So the first student had a much, much better quality measurement because their measurement was much closer to the true value. It was much, much more accurate. The problem is this, though. We want to compare the accuracy of measurements. You have to be able to have a way of comparing the accuracy, calculating it. You can't just say, I was 1 centimeter off. 1 centimeter might not be a big deal measuring the length of a room. 1 centimeter is a big difference if you're measuring the thickness of a marker, though. So usually we use percentages. So we use this particular formula. So to determine the accuracy, you want to figure out what the percent error is. How far off are you from the true value? So you use this formula, the MA equation. So you find the difference between the measured and accepted value, the true value. Then you take that and you divide it by the accepted value. And you end up with a percentage. So here's a great example. So I have a pencil, and it was measured and found to be 75 millimeters long. The actual length is 77. How bad is this measurement? How accurate is it? So we're going to calculate percent error. So we use the MA equation. So the measured was 75. Let me just remind you of that. So this is my measured. And the accepted is 77. You find the difference, 2. And then you divide it by 77 which is the true value. End up with negative 2.6%. What does this mean? It means that you're off by 2.6%. And the negative sign says that you're a little bit too low. If I had a positive sign, then it would mean that the measurement was too high. And you have to indicate that with a little statement. So here we have a negative, so the measurement is 2.6 percent below what it should be. Bottom line. Okay, now that we've done accuracy, let's look at an example of precision. So again, precision is how consistent your measurements are. You want to have high precision where the measurements are close together. So to determine the precision, you look at the average of the measurements and you see how bad the worst measurement is. So the way you do that, again, you do the average. So here we've got a student measuring the width of a textbook. They did it 3 times. They recorded the measurements as 24.1, 24.3, 24.4. So you do the average, and again, you round to appropriate significant digits. So here it should be 1 decimal place. So your average is 24.266 repeating. So 24.3 is my average over here. Now, what I'm going to do is I'm going to look at the worst measurement from my average. So here's my average, 24.3. And then I'm going to be comparing 24.1. So I'm off by 0.2 centimeters. The middle measurement is exactly the same as the average. And this last measurement is off by 0.1 from the average. So you can see this is my worst measurement. It's off by 0.2. So what I do is I write down the average, 24.3, and then write down plus or minus, and then I write down the worst range. So I'm off by 0.2, which isn't too bad as a result. So again, that's how you calculate precision. Fairly straightforward. Let's look at a real life example. So the other day you were dropping objects from your desk. So I have here some typical data from 2 groups. One group had these results. Group B had these results. And my question to you is, which measurements were more consistent? So to figure out consistency, remember you want to figure out how, what the worst measurement is from the average of all of these. So let's look at that. We got our average for both, 0.3 on this side. And now we're going to determine how poor or what the worst measurement is in terms of the range. So the first measurement was off by 0.1 seconds. The next one was off by 0.7 seconds. And the last one was off by 0.6 seconds. So it looks like the worst measurement is this one, is off by 0.7, or sorry, 0.07, I should say. I made a mistake there. Sorry, folks. And what you do is then do this. You write down the average for the precision. So 0.30 plus or minus. My worst measurement was off by 0.07. So 0.07 seconds. That's the consistency here. Let's look at group B. So group B, we have our average over here. The first measurement was off by 0.1 from the average. This is off by 0.2. The next measurement's off by 0.2 as well. So here, my measurements are 0.43 plus or minus worst measurement 0.2. So we can be 0.2 seconds higher or lower. So clearly we can see that this set of measurements are much more consistent. Just looking at the data, you can see that too. They're not far off from each other. Okay, next question. So if I have these measurements, if the time should have been 0.34 seconds, which measurement was more accurate? So to do this, we have to calculate the percent error. Right? Remember, it's my MA equation. We're using our MA equation to determine the error associated with both sets of measurements. So here we go. I've got my measured value here. I'm going to use the average when I'm comparing it to the true value. So my average for the first set is 0.3 seconds. The value should be 0.34 seconds. And on this side, the average is 0.43. It should have been 0.34. You do a little bit of fancy math, and you find that the first set of measurements are below what they should be by 12%. The second set of measurements are too high by 26%. So which measurement was better? A measurements were much, much closer to the true value. So that's it. That's about it for determining the accuracy or precision. So how close are you to the true value and how consistent your measurements are. You are going to have some practice worksheets and some practice questions on you in your workbook page. We have a few here. I'll have those posted for you. So hopefully you have an appreciation for how important it is to really take your time with measurements and try to make them as good as they can be. Take care. Bye.